Hello and welcome. My name is Jennifer Gates, Field Services Director for the California Preservation Foundation. Thank you for joining the first webinar in the California State Historic Building Code series entitled Fire and Life Safety Requirements. The California Preservation Foundation is a membership-based organization whose mission is to provide statewide leadership in education and advocacy to ensure the protection of historic resources in California. Information on our membership and educational programs can be found on our website at www.californiapreservation.org. The format for today's webinar will include a presentation followed by time for questions and answers. There is a toolbar on the right side of your screen. If you have a question at any time during the presentation, please type it in the box and I will hold the question until the end for the presenter to answer. You will be muted throughout the presentation. To hide or unhide this toolbar, click on the orange arrow. Today's presentation will be by Stephen Farnath, a founding principal of Architectural Resources Group. Steve brings 30 years of experience in the field of architecture and planning. He is a nationally recognized expert in the design and rehabilitation of architecturally significant buildings and sites, and is particularly knowledgeable about the California State Historic Building Code, serving on the executive committee of the California State Historical Safety Board. He served as vice chairman of the U.S. Committee of the International Council of Monuments and Sites for 10 years, and has served on the steering committee for the Getty Conservation Institute's Seismic Adobe project. Steve leads ARG's Sustainable Design Studio, integrating sustainability issues into all of ARG's planning and design projects. Thank you for joining us today, Steve.
Thank you, and welcome everybody. Is this where I begin, Jennifer?
Yep, it's all yours.
Okay, thank you. Well, welcome everybody. What we're going to be talking about today is the California Historic Building Code, and particularly 3 chapters relating to fire and life safety. So, Jennifer, I'm not getting this thing going forward.
Here, let me, just one second. Okay, go ahead and try again.
There we go. Okay. Well, that's the title slide that we were looking for. I'm just going to talk for a second about the background of the California State Historic Building Code, because it was really an early idea in code writing in the country. It was originally written in 1976 by a number of people, most significantly Ray Gravigian and Clarence Cullimore. Clarence Cullimore was a state parks architect, and Ray Gravigian was a practicing preservation architect in Los Angeles. In those years, I've been asked to speak about this because I'm one of the few people old enough to remember those years. Historic buildings were being gutted in the name of code compliance as we would try to rehabilitate them. Basically, structural issues or fire protection issues, they really were not capable of meeting the code requirements for new buildings, and yet everyone recognized that there were capacities in historic buildings for life safety that weren't being recognized. And so the code was written, the Historic Building Code was written with an idea as a performance code, which was to write a code in a fairly open-ended manner that would identify what the performance objectives were, rather than very prescriptive, thou shalt do this or that. And at the time, that was a fairly new idea. It's no longer a new idea. Performance codes are becoming pretty much the standard. When it was written in 1976, it was an optional code which could be accepted by different building departments. but generally speaking, it was kind of a rough go to get building inspectors to go away from standard code interpretations to think about things which were outside the box of standard regulations. In 1984, the code became mandatory. The state required all building departments within the state of California to recognize and accept the provisions of the State Historic Building Code. And from that time on, both practitioners and building officials and building engineers became gradually more and more comfortable with how to work with this code and how to allow the code to assist in preserving buildings without a diminished amount of life safety. Currently, the California Historic Building Code is embedded in the California Building Code as Chapter 8. And I'll talk a little bit later in the presentation about how the two codes work together.
Steve?
Yes.
Can you, we've had a couple of requests to have you speak up a little bit, please.
Oh, certainly. As I mentioned, the purpose of the code is to facilitate preservation by providing for alternative code solutions to the requirements of what is referred to as regular code, which is actually the California Building Code. The code, Historic Building Code, it provides some alternative solutions, but what it really does is provide for the possibility of identifying alternative solutions which are capable of meeting the intent of the regular code. And the Historic Building Code applies to all issues of code compliance for qualified historic buildings. Now, a qualified historic building is defined in the State Historic Building Code as buildings or properties on or determined eligible for national, state, or local historical registries or inventories. That's a slight change over earlier years where the buildings were required to be formally listed either by a local jurisdiction or state or national. Now being determined eligible is adequate as a basis for being determined as a qualified historic building. I'll go through the three chapters we're going to talk about as an overview first, and then we'll talk about a few case studies or examples of how the code works. Chapter 8.3 is use and occupancy, and this chapter, the purpose is really to talk about requirements for change of use or continuing use. And just a couple of points which are very important in the chapter. One is that an existing use may be permitted to continue regardless of any period of time in which it was either unoccupied or if use requirements have changed, so that historical uses are acceptable. A second important point is that if there is a change in the use or character of the occupancy, that change in occupancy does not mandate conformance with all the new construction requirements set forth in regular code. So this is a really important distinction that the State Historic Building Code gives us. You can change the occupancy without being required to bring every aspect of the building up to current code. In reality, as you change occupancy, there are many things that you do have to change and adjust, but this is an important distinction that it's not a trigger to require every aspect of regular code to be triggered. Other aspects of this section, maximum floor areas are extended, particularly when the building is provided with an automatic fire sprinkler system. And you'll see as we go through this, I'll keep saying as long as there's an automatic fire sprinkler system, and that actually, as in practice of using the code, installing fire suppression systems in these buildings is the most important thing you can do. It gives you the most flexibility, and actually practice has shown us that it gives a tremendous amount of added life safety. So we'll be repeating that mantra pretty much through the entire presentation. The maximum height and number of stories that are defined in the regular code for particular occupancies are not mandated. Building can exceed those height and number of stories if it's a qualified historic building. There's a relatively recent provision in the code for high-rise buildings now. This is in the most recent edition because we're starting to see historic buildings that are high-rises, and prior to that we hadn't been really looking at high-rise buildings. One element here is that buildings over 75 feet, the first 75 feet in height, are not mandated to be have fire sprinkler systems, but above that are mandated. In actual practice, it's been my experience that you would just go forward and add the sprinkler system no matter what. Other provisions of this chapter, flexibility in meeting the light and ventilation requirements of regular code, both in terms of the amount of light and ventilation, but also in terms of how that light and ventilation is delivered. Even if it is in some way hazardous, you must go back and mitigate the hazard in some manner, but light and ventilation can remain. Chapter 8.4 is fire protection, and the intent of this chapter is to look to the life safety of occupants in terms of fire separations, rated walls, and that sort of thing. And the specific areas, perhaps the most important, have to do with requirements for fire restrictive construction, fire resistant construction. These are made much more flexible, both in terms of exterior wall requirements and the requirements for 1 hour construction. 1 hour construction can generally be not required, provided that there's an automatic sprinkler system installed, that there's an improved life safety evaluation to evaluate the actual safety level of the building, and that other alternative measures are approved by the enforcing agency. In other words, the fire resistive requirements that would be required by regular code can be adjusted based on evaluation and concurrence with the enforcing agency, provided there is an automatic fire suppression system. Similar flexibility related to openings in fire-rated systems. Requirements for interior finish materials are also dealt with here, and again, because frequently historic buildings have special finish materials which do not meet flame spread or other fire-related issues developed by the regular code. This section allows you to use non-conforming materials, and when there is a automatic fire sprinkler system provided throughout the building, existing finishes shall be approved, is the language of this code. So again, flexibility provided that there's some alternative way of suppressing fire. Wood, lath, and plaster, there's a special paragraph that defines a fire rating for existing wood stud walls with lath and plaster. In the past, that was not recognized. Currently, it's seen to be a minimum of a half-hour fire-resistive rating. Vertical shafts, again, you can treat them with fire sprinkler systems as long as they're blocked at every floor. Roof coverings is one area of the code where there's been quite a bit of pushback, properly so, I think, and this is in the area, the code allows for historic roofing materials, even where fire-resistant assemblies are required. And it specifies a Class B roof or Class A assembly roof in areas of urban wildland and high fire zones. Many of the fire departments have actually pushed back on that, just because of, even with a treated wood shingle roof in a high urban wildfire interface zone, the flammability of these roofs is still under discussion. But the State Historic Building Code argues for permission of the use of fire-treated wood shingles. In actual practice, many owners in other jurisdictions will not really go to the mat for this, just because of the high danger in some areas of California. There is another section on, it's actually referred to as other technologies, and this is an important element because we've gotten much more sophisticated in our ability to model fires and to actually model computerized modeling of egress paths and patterns. And the code recognizes the use of these technologies as a way of understanding how the building will actually perform when it's burning or when people are trying to get out of the building. So in situations where you have some sort of unique characteristics to the building, the code will recognize some of these other methods for analyzing the hazard. Recently, we were able to use fire modeling systems in looking at the Ahwahnee Hotel. And while they didn't actually change what the ultimate solution was, which was to pretty closely meet requirements of regular code, it did provide quite a bit more information about how the building was going to perform in a fire. So these technologies are important to think about as you work on historic buildings. And then the third chapter is means of egress. This chapter has a number of very important elements. The intent is to recognize unique or asymmetrical ways of getting out of buildings. It's not always necessary to meet all the requirements of regular code, provided that you allow for adequate means of egress. And how you meet those requirements, there is some range of flexibility. Some of the specific elements here, existing door widths and corridor widths may be accepted in smaller dimensions than mandated by regular code, provided that you can convince yourself and the building department that there is sufficient width and height to permit occupants to exit the building. Existing stairs, there is a recognition that historic buildings have risers and treads often that are unique and may not meet the very specific requirements of regular code. These configurations need to be analyzed and verified with the enforcing agency, the building department or the fire marshal, that these conditions do not constitute a distinct hazard. In practice, stair rise and run is very important. It really, people have certain expectations, and so the path of egress and the way you move up and down stairs is very important. There's flexibility for how handrails exist. Many historic handrails do not meet the specific requirements of existing buildings. Main entry doors, generally speaking, main entry doors are required to swing out, but if you have other means of egress which provide an adequate exit width, main exit doors may remain. And fire escapes are a very important element recognized in the State Historic Building Code, both existing fire escapes and new. Many buildings, historic buildings, were built with very limited egress paths, and fire escapes have been added over time. In many cases, those fire escapes can be retained and can be considered as adequate secondary means of egress. In addition, the code has some detailed provisions for installing new fire escapes in lieu of full new exit stairways. And frequently, while we don't always like looking at fire escapes on buildings, they serve the purpose of preserving major interior demolition to create a second egress stair. And so, in fact, sometimes fire escapes are very good preservation tools. And finally, handrails and guardrails. Every historic building has some issue related to code compliance with current code for handrails and guardrails. These are very important. Again, stairs are not just egress paths, but they are a bit hazardous if you don't have something to hold on to. So the code allows existing railings and guard railings to remain in their historic height and spacing unless a distinct hazard has been identified or created, both by change in occupancy or an existing hazard exists. In practice, I mean, this is a very open-ended statement, and in practice, we tend to look to improving the safety of handrails and guardrails, perhaps not meeting the letter of the code in terms of 4-inch ball, but certainly being very careful about edges where guardrails need to be 42 inches and the historic height might only be 30. These are hazardous situations that need to be attended to, and generally the design professional and the building official need to come to some agreement on what is an adequate level of safety. In looking at code issues on historic buildings, it's important to take a very comprehensive approach at the beginning of the project. And by comprehensive, I mean not strictly looking at limited areas or limited details of code deficiencies, but actually looking at all the needs of the building, both in how the building will be reused, if it's an adaptation to a new use, what other interventions you might be making, such as structural interventions or mechanical, electrical, or programmatic changes in areas of the building, and do that in compliance, excuse me, at the do that at the same time you do a comprehensive code study. And the comprehensive code study would use the California Building Code to identify all of the areas of deficiency that the building has under regular code. And then as you begin to plan all the changes, you can, depending on how you configure the building, depending on how you organize the changes, frequently you can solve many of the code problems that you've identified, and you can solve them by meeting regular code without destroying historic fabric. And then these comprehensive solutions are kind of embedded in the design. So the process for doing that, which I alluded to, is once you understand the program needs of the building, do a comprehensive code study and identify all of the deficiencies under regular code. And then outline what would happen to the historic features if you actually resolve them under regular code. In other words, the guardrail's too low. If you replace the guardrail to meet code, what happens? Well, you would destroy the guardrail, so you probably don't want to do that. But to have that outline is the first step. Then identify what alternative solutions or mitigations might be possible that would still allow you to meet the life safety objectives of the code, but at the same time preserve the historic fabric of the building. Once you have identified what you believe are potential alternatives, meet with the building official and or the fire marshal to work through them and get a consensus agreement that these proposals are consistent both under the State Historic Building Code and under the judgment not only of the design professional but the fire marshal. And once you have that consensus, then you document it in writing as part of the permit process, so that there's a lot of clarity and transparency both on what the design professional is putting forward and what the building department is accepting. It's very important in the record in the future. And the last point is that the solutions that you come up with are frequently interdependent, and you need to be careful that you don't, if frequently our projects end up being built in phases. Sometimes the code solutions are not really feasible. You have to think about them as one comprehensive package, and then make sure that as you may break the project into different phases, that the required interventions for life safety are consistent through every phase. And that's an important thing to keep in mind. I'd like to now just walk through a few projects where the State Historic Building Code has been used, as just to give some examples for types of solutions to life safety fire protection problems. And I'll start with a pair of 1890s unreinforced masonry buildings which had been vacant after the Loma Prieta earthquake, and they were to undergo comprehensive seismic strengthening and adaptive use to a mixture of uses including classrooms, offices, and student services. Both buildings were built in the same era, as you can see. Some of the problems relating to egress and fire safety, both buildings, the floor plan is for one of the buildings, had essentially one primary stairway, and there was also a turret stairway which was wonderful but made out of stone and really not capable of serving any egress function. And fire escapes had been added at each end of the building to provide egress. we studied the possibility of adding a fully compliant fire stair, but because of the central nature of the primary stair, we would always end up with a dead-end corridor. So the further we looked at it, the more attractive these fire escapes began to look. And so the solution to egress in this case was to leave the fire escapes alone, install automatic sprinkler fire alarm systems, add enclosing doors on magnetic closers, which would allow the main stairway to be enclosed in the case of a fire, and add improvements to how one got on and off of this fire escape. So these are the fire escapes. They're pretty nondescript. It would be nicer if they weren't there, but our opinion ultimately was that this was actually the best solution for the building in terms of both historic fabric and life safety, and actually not incidentally cost. The corridors had wood wainscot. These are doors on magnetic hold opens, and at the end of the corridor are two double hung windows. One of the windows was reworked to be a casement operated door. We kept the sill at the sill height, added exit signs, and this provided an adequate means of egress to the fire escape. In conjunction with that and the enclosure of the stair was treatment of the guardrail, adding a freestanding guardrail extension and adding code-compliant handrails to the outside walls. The other building, Scott Hall, had very similar sets of problems. Only one stairway, which in this case was round in a turret, providing exiting from what became an assembly space. Solutions were very similar. There was an existing fire escape which had been installed in the 1960s on two locations in the building. We chose to leave them in place. In fact, they provided exit capacity in the right locations. And then enclosed the circular stair again with a magnetically held open door, full sprinkler system, full fire alarm system, and then improvements to the guardrails and handrails to make the stair a safer path. This is a view of the assembly space. It's actually a student lounge. And the changes that were made to one of the windows to allow for access to the fire escape stair. And the curved stair itself went up to plus 2.5 stories. And again, a freestanding guardrail extension was added inside the historic stair. So the historic balustrade was essentially unchanged, and a new handrail guardrail was added, which traces the path all the way down the curved stair. This will be a similar story. Another project which really began with a seismic strengthening requirement. We really saw a number of very serious other code issues having to do with unenclosed open stair and corridor egress corridors, as well as guardrail issues. This is a plan view. So there was one open stair at one end of a long double-loaded corridor, and then a second stair 3 stories high. Some of the requirements were decided on to, again, enclose the stairways with doors which could be remain open on hold opens until the fire alarm required the magnetic closers to close. This is an interesting story of the guardrails. I'll get to the photograph of that in a minute. And then making the guardrails and handrails safer. And then looking at how to treat the what would normally be a fire-rated corridor. This is a view of the stairway itself and the new doors on hold opens leading down the corridor. And here's the stair. The corridor itself, and this is a fairly standard type solution, very beautiful corridor with glass transom windows, glass in the doors themselves. In the past, to make a 1-hour corridor, we would have ended up taking off the plaster and sheetrocking, taking out the doors and putting in rated doors, and taking out the transoms. The State Historic Building Code allows these doors to remain as long as they are on fixed closers. And the transom windows are fixed shut. And the idea here is that the flame spread is not so much the issue because you have you have a fire suppression system, but smoke is still a big problem moving through the building. And so it's important that these openings, while you don't necessarily rate them, be closed or be on closers. So that's a fairly common solution now under the State Historic Building Code for the requirements for rated corridors. And then this is a view of the stair, which we already discussed. Again, it's a very frequent solution. There are always different ways to do it depending on the configuration of the stair and the height of the guardrail. This is a guardrail extension. It brings it up to 42 inches and is configured in such a way that you could actually still use the handrail, the top of the old guardrail as a handrail, and this addition just gives you protection from someone falling off the edge. Just gives you sort of a sense of what it looks like. And this was a unique problem. The building code requires a guardrail to meet a certain horizontal force. I believe it's 20 pounds per square foot. And many times we are not asked to do this, but we do think about it. We push on the guardrail and make sure it seems like it's beefy and strong. But it's very difficult to actually prove it. Our structural engineer didn't feel like he could prove it in analyzing whether this guardrail would actually stand up to a code-imposed horizontal load. So what we did was impose a test load on the balustrade, on the guardrail. Fortunately, it passed. If it hadn't passed, then we probably would have added some sort of vertical stiffeners that would have added a level of stiffness to the guardrail. But this type of testing to establish what the actual performance of a historic assembly is a key piece of the State Historic Building Code, and it has impacts in many different areas, particularly structural. Sometimes we'll do a test load on a roof to prove it will meet some percentage of code-imposed snow load, or We will have a special assembly that we may have to test. And we worked on a Frank Lloyd Wright house a number of years ago where it was made of several sandwich pieces of 1x, and we had to prove that it would meet a certain level of shear, and so we we mocked it up in a lab and tested the shear capacity of that wall assembly. So the State Historic Building Code recognizes proven tests or recognizes capacities that you are able to prove through testing, and that's what this guardrail test was about. Got a lot of examples here. This is another seismic upgrade project. It began with that in any event, large assembly sanctuary. The church had been added on to in the 70s, this addition, which in plan is here. And actually the church and congregational hall, fellowship hall, and chapel, garden, and other spaces all existed on separate properties, and in conjunction with seismically strengthening the historic building, what we wanted to do was create an internal spine, circulation spine, that made all of the buildings connect and interact and interrelate. The requirements for a 4-hour wall on the side of the sanctuary limited how this 1970s edition was built. So there was no interaction between the two buildings. So by using the State Historic Building Code and a fire sprinkler system and other opening protection, what we were able to do was, excuse me, let me go back to that, was to create essentially an open lobby that allows all the spaces to interconnect. But the key to being able to do that was the State Historic Building Code allowing a 1-hour rating on this space, and we achieved that simply through sprinklers. It made a huge difference in the way the church operated, provided a space internally to connect throughout the building. So this is a way where the State Historic Building Code can be used not just for preservation, but really for rethinking how historic buildings interact with their neighbors. Oh, I keep forgetting. I got more and more of these. Okay, so this is a 1880s opera hall, Napa Valley Opera House. It had been vacant for a long time, one of the few remaining second-story opera houses in California. It was rehabilitated to become a performing arts hall with all the requirements that that entails. Most of those requirements were not in existence in 1880. And a few of the issues include separating the theater space from the lobby and from an adjoining performance area. There was only one exit stair from the second floor of what was originally a 1,000-seat theater. It became a 500-seat theater. There was only one stair egress from the balcony, which was a curved stair, which had dubious rise and run, and a number of other issues, including the guardrail at this curved balcony. Some things, this is where I was talking earlier about the comprehensiveness of some of these solutions, we really had to separate acoustically this performance hall from everything around it, but especially from the lower level lobby. So the process of actually making a separation allowed us, making an acoustical separation, which is done in this case with several layers of sheetrock, allowed us to create the 1-hour barrier. Of course, everything was sprinklered. We added a second means of egress, both from the balcony and a new egress stair from the hall. So in those areas, we really did not rely on a lot of flexibility from the State Historic Building Code. We really looked to create appropriate means of egress to augment what was there. And then reworking the curved stair so that it could still serve its function, but do it in a more safe manner. A few other things. The original two-story stair had to have, we need again to do this acoustically as well, we had to have doors from the theater space into a lobby and then a second set of doors to get into the stairway. Actually, that's at this level, coming down. A second stair was added that in the back of the theater that would come all the way down and egress through the main lobby and out into the public way. And a second stair also from the balcony level. So there were, even while we used the State Historic Building Code, because of the assembly occupancy, because of the number of occupants, and because of the tenuous nature of some of the egress systems, there was a fair amount of upgrading in this project. These are a couple of views of the curved stair. This is in the state that it was found. An amazing piece of structure, actually, all made of wood. The guardrails had already been removed, but they were restored. And because the rise and run was so tight on the curved inside radius, we chose to locate a new handrail, not on the historic handrail, but inbound, so that we forced the person using the exit stair to walk in an area where the treads were of a reasonable width. You can see that here. That greatly improved the safety of the stair. Fortunately, it was quite wide, so we didn't reduce the adequate width. And a final example, this is Pershing Hall at the Presidio. It was originally a bachelor officer's quarters from about 1910, and it has been adapted to a 22-room hotel. Basically, this is an interesting story because it was largely all there, although a lot of the finishes in the rooms had been upgraded in the late 1960s, 70s. There hadn't been a lot of structural changes, so all of the historic walls and floor configurations existed. The building had fire escapes added, particularly this one right on the front facade, which particularly unfortunate, as well as ladders, this ladder on the side, to provide second means of egress from all of the officers' bedroom quarters. In looking at the issues on this, one of the primary and early decisions was to keep it. The original bachelor officer had a bedroom and a sitting room, so they were two-room suites with a small bathroom. And in working with the future operator, we made a very important decision, which was we're going to live with that suite type arrangement. And by doing that, we reduced the amount of, we didn't add to the egress conditions, and we allowed each of the two-room quarters had its own door into a stairway. So rather than a corridor or any other kind of internal egress system, Pershing Hall had 3 vertical stairways, and each stair connected at each floor level to a room. So in planning for the adaptive use, we took both the preservation issue, which is to keep the quality of the spaces intact, and also the configuration of the egress circulation. So That made the problem easier, or at least we didn't make the problem harder. But we still needed second means of egress from each of the sleeping rooms. In addition, the stairwells had to be separated, so the doors were on closers. And we had guardrail issues, as always, particularly at the two-story porch that runs across the front of the building. One of the owner's programmatic requests was to get rid of that fire escape on the front facade and to rethink the ladders that existed in other parts of the building to provide a different form of egress. And so we removed the existing fire escapes and then rethought another way of egressing from the upper rooms. And this is the rethinking that ended up as a solution, and that is to provide an egress platform at the rear of the building on the second and third levels from sleeping rooms, and adjacent to what is essentially a fire escape platform is a folding ladder. And these things are made by Jomi. That's what you see here on the right. On a day-to-day basis, they look like a downspout. If there's a fire and you're on the balcony, there's a lever, and you push the lever, the stair comes out, the ladder comes out, and you egress the building. So this downspout-looking thing actually becomes a ladder which supports both this balcony and that balcony. And the code allows this type of solution, but it's something that really needs to be worked through both in terms of the number of people who would be using it, in this case two rooms that it's serving, and what type of hazard you see in the building, and really working closely with the fire marshal to assure that they approve of the solution. In this case, it's a National Park Service fire marshal who is the AHJ. And then guardrails. The second floor, about 15 feet off the ground, clearly as a hazardous condition, it was important to add a guardrail extension, which is what you see here on the right, up to 42 inches. But at the lower level, we just exceeded the 30-inch maximum height. It varied. It probably went up to about 4.5 feet at the low end of the porch and down to 2 feet or less at the upper end. And we felt this did not constitute a distinct hazard, and fire marshal agreed. And so in this case, we left the guardrail as built. And it's about 33 inches, I believe. So it's not inordinately low, but it certainly is not meeting the current code. Our feeling was that, however, that it was not a safety hazard. And fire marshal concurred. And this is the front facade of the building now without the fire escape. And that concludes my presentation, and I think we have about 30 minutes left for questions.
Yes, we do. And thank you again. So at this time, if you have questions, we do have some already, but if you have a question, please type it into the box, and it'll be sent to me, and I will ask Steve now. So the first question that we have is, could you please define what a Class A roof is?
I may not be able to do that. I believe the way to achieve a Class A roof, actually, no, I don't have that in front of me. Class A assembly would be defined in the California Building Code. It's not in the State Historic Building Code. It has to do with the rating of the roof covering. I believe wood sheathing plus composition roofing does achieve a Class A rating. And I believe that simply unprotected wood shingles, it would be a Class C. And I may not have that exactly right, but Class A essentially is a flame-resistant material and assembly.
Okay. Next question. Is there an average cost per square foot for installation of an automated fire sprinkler system?
Yes, there is. I can't tell you what it is. I can tell you that in many cases with private owners, the cost of installing a fire sprinkler system is paid by over a relatively short period of time by the improved insurance rates that the owner gets.
Okay. Next question is, okay. Why is the Awani required to meet the California Historic Building Code?
It is not. The National Park Service uses they have the ability to define their own codes. They normally use the International Building Code. They also recognize the NHPA. The California State Historic Building Code, as it is in other areas, is sometimes referenced just as another way of looking at a problem. It's not the prevailing code, however, for a federal building.
Okay. Next question. Does the DSA have special provisions for university or private school facilities?
The state has a requirement, I believe it's called the Private School Safety Act, and it provides for the requirements of private schools, and essentially requires private schools to meet, I believe, almost all the same standards as public schools, but that's not, I don't believe, mandated through DSA, but through separate statutes.
Okay. Next question. It looked as though the egress window with the crash bar at Scott Hall was quite high off the ground. How high is acceptable for egress?
That's a good question. And that is quite high. I believe it exceeds 30 inches. And I don't know that there's a specific standard for how high a sill can be. In that case, that was the opening that we had to work with, and yeah, that's all I can say. I'm not familiar with if there is a standard for what a sill height can or should be, but yes, that's a little high, that one.
But that you would work with the building official on each case individually?
That's correct.
Okay. Next question is, where in the Historic Building Code does it define the process for identifying existing non-compliant code conditions and presenting to the building department for discussion, if it's in there at all?
Well, Chapter 8.1 discusses the administration of the code. It may not mandate exactly the process that I went through, but basically that is the, I think, standard operating procedure or standard practice at this point. That it's essential that the building department understand what issues exist with regular code in order to look to what possibilities exist for alternatives.
Okay. While we're on that subject, can you just briefly touch on the State Historic Safety Board and their role?
Yes. The State Historic Safety Board was created in parallel with the State Historic Building Code. Initially, in the early years of the code, the Safety Board was very, very busy because it was formed as an appeals board. So if a building department disagreed with an owner's request or position under the code, those issues could be brought to the board for a hearing, and the board, which is constituted of architects, engineers, fire protection people, representatives of a number of state agencies, including the State Fire Marshal, State Department of Rehabilitation. There's a housing seat, State Contractors Association, AIA, actually building officials, whatever the official organization of building officials is. All those people on the board represent very differing constituencies and abilities. And so their mandate was to be able to interpret the code and provide an appeals mechanism. In the early years of the code, that was a very, very busy activity. But over the years, it's become less and less so as building departments have become more comfortable with certain provisions of the code, and the actual use of the code has become fairly more common. We have seen appeals in the last few years, that's what I mentioned earlier, of a number of fire protection agencies and the use of the State Historic Building Code for wood roofs in urban wildfire areas. And that's been the biggest appeal area. Most of these things are now settled at the building department level. But the primary purpose of the safety board was to serve as an advisory and appeals board. The last number of years, there haven't been many, but the other function of the board has been to edit each subsequent edition. So I think there have been 3 or 4 rewrites or tweaks to the code, and that language comes from the State Historic Safety Board.
Okay.
The board also is supported by an executive director, and in fact, Richard Conrad, who's the executive director, is available for questions and interpretations, and he, if anyone makes that call. But he also then organizes the agenda for the safety board, which meets 2 or 3 times a year as necessary. So Richard sort of manages all of that, as well as organizes the process of code editing.
All right. The next question is, will you please discuss possible solutions for window height code restrictions? For example, the bottom edge of windows under current fire code are too high.
Yes, that's a really good point, and it was made earlier. In each case, I think you would have to look at how to get to that windowsill. And the image I showed of Scott Hall did not have a step or a couple of steps, but I kind of remember that, in fact, we ended up doing that. I don't know offhand what the appropriate or reasonable level for a windowsill is. I think in a sleeping room, it doesn't exceed 30 inches, but not sure of that. And the process, again, would be to look at what the existing situation is, what the egress requirements are, what the existing sill height is, and then work with the building department to identify what's a reasonable level of safety.
Okay. The next question is, Section 8032.1 allows existing use. How far do you go when many uses existed after the original occupancy?
I'm not sure I understand. You mean how many existing uses would be possible, or?
Yeah, after the original occupancy. So maybe the existing use had changed multiple times since the building was constructed for a specific occupancy, and that use had changed a couple of times.
That's a very interesting question. I guess, and it would, again, everything is sort of unique. It really depends on what the conditions are, but my initial take on that would be that the state would recognize the use that the building was designed for. If the use was subsequently changed, but the building was not, then that intermediate use would really have relatively little to do with. The idea here is that buildings were built with some idea of safety in mind originally, relative to the original use, and the more alterations, the more change of use without alterations or with minimal alterations, the farther the building gets away from any relationship between its design and its use. So without knowing more, this is sort of a academic question. I would say that really the code is only talking about the original use and the original building. The intermediate ones would be subject to a different discussion.
Okay.
We have been involved in a number of kind of interesting issues. One of the big things with this early on was conflict between building code and planning code. So whereas the owner of a building that perhaps once was a hotel wanted it to remain or return to that use, the zoning of that particular jurisdiction no longer permitted it, for instance. And so while the State Historic Building Code would recognize the use for the building, there was a big dispute about whether it applied to planning codes or not. And I can't remember exactly how it resolved itself. I'm not sure that it resolved itself easily, but this is primarily a building code and not a planning code.
All right, the next question. What is your experience dealing with professional liability insurers and/or attorneys regarding less than regular code solutions?
Well, the State Historic Building Code is a building code. So provided you are careful with how you analyze a problem and how you document the solution and how that solution is recognized either by other jurisdictions or the jurisdictions who apply, is the most basic element of being concerned about liability. Early on, there was a great deal of concern about this, but in our experience, it hasn't turned out to be either a problem with our insurance carriers or a problem with claims, provided that you really need to be careful both in documenting the solution both to the file and to the jurisdiction. In some jurisdictions, in the early days, use of the State Historic Building Code had to go through a building appeals board, and that was a very formal process. And I used to think that was a very good process because it really spread the ownership of the solution, but it's also quite cumbersome. So the way it works now is quite a bit more direct. And in our experience, it has not been a major liability. You also need to not take advantage of this performance-based code. You still have to find ways for the building to perform adequately.
Okay. Next question. There is a high reliance on the provision of sprinklers as a means of historic preservation in the building code. What are your thoughts as to the detriment to interior fabric from the installation of a sprinkler system?
The advantages are so great that it's kind of a non-starter, but it's really worth asking the question. And how you go about installing the system, how you detail it, and what kind of methods you use to install it are all very important. As an example, the life safety project at the Iwani, which we were working on, used 4 different types of pipe depending on what part of the building we were in. In some areas we used copper pipe because it's much easier to conceal in a wood ceiling. It's a little bit harder to work in some ways, but the pipe sizes are smaller. We used stainless steel in another part in the kitchen where we wanted to prefabricate everything and put it up quickly. And I believe we even used PVC in a couple of locations. So I think you have to think very hard about how you detail and install the sprinkler system. But the benefits of it for life safety and preservation are so great that I haven't run into I don't think of any situations where we wouldn't install a fire sprinkler system. Now, there are a few caveats to that, and that is, for instance, an adobe building where you need to be kind of careful about where you put the water because you could turn the building to mud and put out the fire. And so in those cases, the fire protection people we've been talking to have been suggesting mist systems. A mist system is relatively new. Instead of putting out a high volume of water, it puts out mist. And I believe it came about through the cruise ship industry, where you don't have either space or working area for a full-blown sprinkler system. Anyway, misting systems are kind of interesting, and we're doing that on another project where there's a very delicate plaster ceiling where we don't want to penetrate with the sprinkler system. We also have no clearances above it, so we're installing a mist system which has it's pressurized in a different way, smaller pipes, smaller heads. So there is technology, and there are ways to create fire suppression systems that don't destroy historic fabric. But even some small alterations are worth it for the benefit you get from fire protection.
Okay. The next question is in regards to interior finishes, and what kind of concessions have you seen? For instance, historic theater wall curtains.
I haven't had any experience with preserving historic curtains at the proscenium arch of a theater. Not exactly sure what the solution might be. It might be that you have a fire-rated curtain directly behind it, or that you alter the curtain in some way so that the historic curtain is essentially a veneer over something else. Wall finishes themselves run the gamut. There are conditions where you're concerned about flammability of wall finishes. We've used intumescent paints in those conditions a lot, where intumescent paints give you some fire protection on the surface, provided additional fire protection from, for instance, normally painted wood. So that's one other alternative to achieve some flame spread improvement.
Okay. How do you determine the extent of scope of work, also to determine the fees on historic buildings until you actually start getting more information?
This is a question my partners have been asking me for 35 years, and I haven't got it right yet, but my approach has been to always quote too low of a fee and end up losing money on the project because the projects are so much fun. Anyway, it's very difficult to be serious about it. What we do, we look at pre-design as the most important phase of the project. And a lot of times we will have a separate fee for pre-design, and we won't really quote the fee for design development, construction documents, or construction administration until we feel that both we and the owner have our arms around the whole scope of the project, both what the construction budget needs to be and also what special design issues we're going to face as we go forward. A lot of the planning time in historic preservation projects is in pre-design. A lot of the actual additional fee cost is also in pre-design. Once you really have established what all these issues are, preservation projects are not much different from any other design project. So we will try to work through the pre-design with some sort of a fee that may be flexible, but in any event, we would try not to commit to an exact fee for the later phases until we're sure that both we and the owner understand what's involved in it.
Okay. The next question that I have is in regards to fire safety evaluation. Could be or should be performed as part of code review and approval process. The question is, who do the authorities recognize as qualified to perform such an evaluation?
I think that depends on the sophistication or the complication of whatever issue is involved. In some cases, an architect is perfectly capable of evaluating what the building code deficiencies are and what the solutions might be. There are a lot of other cases, however, where it's important to get a fire protection engineer engaged. This is a specialty, and I believe it has its own set of certifications. Fire protection engineers, in our experience, are much more sophisticated about looking at fire modeling, all the more specific issues of how flame spreads and smoke spreads through a building. As I mentioned at some point in that earlier slideshow, there are very sophisticated computer programs now which will look at what happens, how much smoke is generated by a couch fire versus a fire in one chair versus a fully engaged table. All that can be modeled and requires a person with sophistication if that's the path you choose to take. So I think the answer to the question is it really varies depending on how complicated the problem is. But once it gets beyond an architect, you really need a fire protection engineer.
Okay. Kind of goes along with that is what if the regular code requires more than a 1-hour construction, how does it get reduced to 1 hour? Could it?
I think we have had situations where we require a 2-hour wall, and in those cases, I'm not thinking of a specific. However, so where those requirements exist, sometimes you simply have to make some intervention. You might have to change out doors to have the required separation. You may have to add a second set of doors, or you may have to change finishes or wall assemblies.
Okay.
I don't have a good answer to that one, I guess.
The next question is, you mentioned historic roofing material is one of the areas of greatest pushback currently. What kinds of solutions have been used to get buy-in from the building department?
Well, the most common solution, first of all, there are kind of limited number of situations where in the rehabilitation of a building, a historic wood shingle roof is required. However, we have had, clients who, are accurately restoring the building, and that wood shingle is really part of the character-defining features of the building. And so the solution in those cases usually is to use a fire treatment on the wood itself, but in addition, place a layer of sheetrock under the sheathing to create a barrier between the flame spread of the shingle and the fire getting actually into the roof assembly. And I forget what, I believe that combination of a fire retardant on the wood and sheetrock in the sheathing assembly improves the roof rating to an adequate level to satisfy most of the authorities for Class A.
The next question is, do you have any suggestions or strategies for educating an agency when they have not used the California Historic Building Code and there may be some animosity to repairing historic buildings?
Yes, well, I alluded to that earlier. That's something that 30 years ago was a really common problem in question, and both the architects and preservation side of the coin have gotten more tools and more training, but also the building officials side has become much more sophisticated about the use of performance codes, and so there have, and the capacities of historic buildings. So that situation where a building department is very negative to historic buildings really, I find, is not nearly as prevalent as it once was. If it does exist, what happens now is, generally speaking, if it's on the agency side, there are advocates within the agency for preservation, and so sometimes within the agency they'll get together and amend their attitude, if you will. It's not necessarily up to the design professional. But in the worst case, if you come to a complete block, there's still the State Historic Safety Board appeals process. The other method, which others have used, is to have the building department call the executive director of the State Historic Safety Board, who is very good at using his experience to talk through an issue with the building department. In addition, the board has a couple of very, very knowledgeable building officials on it, and they might be able to speak the same language as fire marshal or building inspector who is reticent to use the code. So those are a couple of ideas, but in our experience, we haven't found it to be a major problem recently.
And this is going to be our last question. We have a few extras. But the last question right now is, have you had experience with creating a fire protection plan for historic buildings? If so, can you explain what this is and when appropriate to use?
Well, we've had experience with planning code improvements for historic buildings, and they almost always have a fire protection component. Generally speaking, we haven't done a separate fire protection. It's always in a bigger umbrella of life safety, egress, building occupants, and preservation of historic fabric. So it's like one overarching preservation plan for the building, of which fire protection is one component. So I'm not sure if I answered that question, but maybe the answer is, from my perspective, maybe the answer is no. I haven't done separate fire protection plans.
Okay. Well, thank you again for joining us today. There are some additional questions, and I will work with Steve to answer those questions, and we'll get those out to you all. Later today, you will receive an email with a link to a survey. We would appreciate any feedback on this webinar, as well as recommendations for future topics. As you can see, this is the beginning of our Building Code webinar series. We have two more, one later this month on accessibility in historic buildings, and then in early September on accessibility in historic landscapes. And we just added a fourth webinar to the series that will be held at the end of November on structural design and archaic materials. I will also send you an email with the final PowerPoint presentation, and we hope that you have a good rest of the afternoon, and thank you very much for your support, and thank you, Steve, again for your presentation today.
You're very welcome, and thanks everybody for listening.
Thank you.